Welcome back to Python scripting for GIS applications, spring semester 2013, University of Alaska Fairbanks. From last time, your assignment was to write a script that would compute the distance from one point to all the other points in a point shapefile. So what we'll do is we'll import our module, OGR, and then we'll get our shapefile. Let's see, so I'll get it using glob just like last time. So search for points asterisk dot shape and return the first element it finds in that list to shapefile. So then shapefile has points.shape. So then we'll create our driver and we'll create our data source and we'll create our object. So our driver to understand Esri shapefiles, and then we'll open our shapefile with our data source object, and then we'll create our points layer. Okay, so then we'll get an attribute filter and we'll select the point that has an ID of 1. And then we'll put that feature in a variable called point feature. And then we want to get the shape field. We don't care about the other fields. So get the geometry and put it in some variable. I'll call it point 1. So point 1 is equal to point feature dot geometry. Okay, so from the point that has an ID of 1, we want to calculate the distance to all the other points in this shapefile. So what we could do is make an attribute filter and pick all the points that don't equal 1 in terms of their ID. And in this case, it should be 3 points. So let's see how many points are currently selected. So it does have those 3 points selected that don't have a point ID of 1. So then what we're going to do is basically get the features from those selected points and then get the geometry and then get the distance. So we'll do this in a loop. We'll say for I in the range going from our first point to our last point. So our last point will be points layer get feature count. So that will be the third point that's currently selected. So then we'll say, okay, point feature 2 is equal to get a selected point. And then we'll grab the geometry or the shape field from that point feature. So I'll call that point 2 is equal to the selected point dot geometry. So then we can calculate the distance between the two. And then we'll just print out the distance. Let's see, point feature dot get field. Well, we know our point feature 1. So then what is it the distance to? So that will be point feature 2. Get field. And we'll just get, the field is called point ID. So inside our loop, print out the distance to this, whatever point we're getting the distance to, and then that value that's been calculated. And then we'll see what happens. So the first time through the loop, the distance between point 1 and point 2 was 1.0. The next time through the loop, the distance between point 1 and point 3 was 1.0. And the last time through the loop, the distance between point 1 and point 4 was 1.41. And those are all correct distances. Okay, sometimes you have a question and it's not the specific distance between features, but you want to select features within a certain threshold distance. So here's an example Python script. And what we're going to do is, for point that has an ID of 2, find all the line features that are within a distance of 1 or less to that point. So basically what we do is we get our points.shape and make a layer. And then in this case, we're only interested in the point with an ID of 2. So we do an attribute filter to select out that point that has an ID of 2. And then what we could do is we'll get its geometry and store that in this point object, and then use the buffer function. So we'll just buffer by the threshold distance we're interested in. So now we've got this polygon object that has a radius of 1 around our selected point. And then any line that's inside that buffer is close enough to our point. So then we open our line shapefile, and then we set our spatial filter to this buffer. So this set spatial filter basically says, okay, select all the lines that are inside that buffer polygon. And then we can simply print out any feature that has it's inside that polygon. So in this case, there's just going to be one line. So I'll just print out the ID of that one line, and that will be within a distance of 1 to our point, and it's to our selected point that has an ID of 2. So we'll run this, and it says the ID of the line that's within a distance of 1 of our point is line 11. So we could double check by looking at this in our GIS. Okay, so here are the 4 points, and in this case, what we did was we had an attribute filter and it selected this point that had an ID of 2. And then we did a buffer and we said, okay, find all the lines within a distance of 1. So we could measure out from this selected point So this line has a distance of 0.71 and it has an ID of 11. So that was selected by our script. And this line is 1.5 meters away. So that would not be selected by our script because it's longer than the fixed distance we were asking for, which was a distance of 1. So basically our script looked in a distance of 1, which would be about that far away, in a circle. And the only line it found was this line 11. Okay, so you could do the same operation in your GIS. What you would do is say, okay, select point ID equals 2, it's selected. And then we could say run a buffer geoprocessing tool and create a buffer with a radius of 1 around our selected point. So that would give us that buffer. And then we could say, okay, select by location the lines that intersect our buffer. So the only line that's close enough is line 11. Okay, so your assignment for our next time is to create a Python script that generates 100 random points, and their x and y coordinates should vary between 0 and 10. And your script should select and print out the xy coordinates of all the points that are inside a circle, and the circle is centered at coordinates x5 and y5, and the circle has a radius of 2. And you could do this by creating a point object and basically buffering your point object to make your circle, and then randomly creating xy values ranging from 0 to 10 and assigning those to a point object in a loop. And I'll go over the solution to that problem in the beginning of our next video session.